Okay, guys, good evening. Am I audible? Everyone can see my screen, right? Yeah, okay. Then let's start the class. So, yesterday we were discussing about MUX, right? Multiplexer. So, we did start at Testbensh, right? So, today we are going to start the class, okay? From Testbench. So, what is Testbench and why we need the Testbench? So, after designing a particular design of an hardware component or a hardware design, okay, we need to check whether that particular design is working properly or not. Like we need to check for errors. So before deploying that hardware design, we need to check whether it's properly working or not. So we need this test bench and simulation code so that we can know that oh, this code is running correctly, and yeah, it's this design is ready for deployment. Okay, so that's why we need test bench. Okay, so this is how that multiplexer test bench code looks like. Okay, yesterday we discussed about multiplex 2 is to 1 multiplexer in which we write Verilog code in three forms by using assign statement, always block using the if else, always block using case statement, right? So for every style of writing we use similar test bench. Okay, there is no change in test bench code. So how to start the test bench code? Okay, like how we design the design code of an hardware, like that only we are going to create a module. Why we need to create a module? Because module is a keyword which is used to create an hardware block. What hardware block we are going to create? We are going to create a test bench block. Okay, why we so we like to use that hardware design, you are going to create a test bench design for that hardware block, and like this we are going to create, and we are going to prescribe that details of a particular hardware. Like if in 2 is to 1 we have two inputs and one select lines and one wire output, right? So that's need to be mentioned after the model. Okay, after creating a model we need to mention that. Okay, so after mentioning we are going to create a UUT. UUT means unit under test. Okay, it sometimes it is called as so DUT also. DUT means design under test. So both will be like same only, but someone prefers it as a DUT. So for now we are going to use it as a UUT. Okay, UUT means unit under test. Okay, so before, like if you give the design name, okay, so we have mux 2 to 1, right? Mux 2 to 1 UUT. So this variable name, okay, this is the module name which we have designed. Okay, so we should use same module name. Okay, with same alphabets. Like if you use mux with all small letter means the name should be proper matching with every alphabet should be matching. Okay, so even if you change m to capital M while you designing mux, if you mention that module small mux, and when like importing that to test bench code, if you mention it as capital MUX means, so it thinks so that is for some hardware design. We are testing for some hardware design. Okay, so always remember that Verilog is an case sensitive. Okay, you should always write the use the same names. Okay, what we have designed, you are used to use that design names inside an test bench code. So after using that creating a UUT, so you are creating UUT and you need to mention what are the what are inputs and outputs to be passed to that UUT. Okay, here I have mentioned a comma b comma cell comma y, right? So this is not a proper way to mention to import that design components to these testament components. So there is a proper way to mention that components is the way is called as map formatting. Okay, map formatting means mapping component of design to a hardware. Okay, so how to do that? It is usually done like this. Module, think module MUX 2 2 1. This was our design name, right? So after creating a UUT, you should need to mention like dot a of a, comma dot b of b. This is the way of mapping. Okay, you need to always write like this only. Why? Because like think in your design code. Okay, wait, I will show you. In your design code, you have mentioned a, b, cell, and y, right? Sometimes the your order changes, like input b, a, cell, like that. Okay, if your order changes means inside your test bench code, here you are like importing that components, right? Input and output. So sometimes it doesn't map. Okay, sometimes it think a is equal to b, b is equal to a, like that. It thinks sometimes. Use so to avoid this, we are going to use map formatting. So by doing map formatting, our code becomes clean and there will be no proper such errors. Okay, so it thinks we are mapping a of test bench code to a input of design code. Okay, like that the mapping works. Okay, so if you are guys writing a test bench code means always use that mapping format. Okay, after create creating a unit under test process, the next step will be like we need to begin our code. Okay, initial means it always starts only once. Okay, so after starting you need to use begin keyword. Why? Because so begin creates an blocks. Okay, so where all your input files will like input procedure states will be proceeded. So after initializing that inputs to the components, you are going to test that input values, right? So after initially begin using keyword, you are going to start that process of testing the test bench form. Okay, so don't think about this dump file and dump where I will explain after I explain this test bench. Okay, so first what is text thinks a is equal to 0, b is equal to 0, then cell is equal to 0. Then what happens now? Okay, so in 2 is to 1 mux I said that if a cell is 0, the output will always depends on a, right? So then the output will become uh, a. So what is a here for first step? 0, right? So it will become 0, and after again the cell is 0. So now the output takes in directly input a as the output. Okay, so this is hashtag 10 means it is a buffer. Okay, you are telling that to your verilog code to wait for 10 units of time. Okay, before starting next step, wait for 10 units of time. Okay, so you like using this buffer helps to reduce the strain on that particular hardware device. Okay, how? Because like if you are processing a one step and then if suddenly you start another step means like if you change the input values means it all like it will create stress, right? Okay, now I am changing to this. Okay, what to do? I can't remember the values, like that. Okay, so we are giving 10 units of time to free up that memory what he has stored for first in try, right? First try it was a is equal to 0, b is equal to 0. Then after your giving 10 units of time as an buffer, then it will take some stress out of that try, and after it's remove some stress, it will go try next input values like a is equal to 0, 1, b is equal to 0, like that. Okay, so and after completing this you are going to end it with using finish means I have tried everything, so finish this. Okay, like that. I will explain this file dump where and finish in after completing this test bench. Okay, so don't think about that, only just think about this input values, like how the it changes and what this hash 10 is doing here. Okay, after this we need to end what you have started. Okay, begin is to start that particular like testing process. After you are completing your testing process, you need to end. Okay, after ending you need to, oh, I have tested now everything. Okay, I'm going to end this test bench module. To end the test bench module, you are going to use end module as a keyword. Okay, so this is how that works. Okay, so I will show you, this is in EDA playground. See here, this is our design code. Okay, so this is our design code. We have used simple assign statement. Okay, so if you are guys trying to run this, then you can use if else always block and case using always block. Okay, so for just now I'm showing with using assign block. Okay, so after that, see here, I have used a mapping. Okay, mapping formatting inside a unit under test process. After that, here don't think about monitor. Okay, I will explain that also. Monitor means it is like it is a keyword which is used to monitor what is happening inside that code. Okay, to monitor each steps. Okay, so monitor keyword is used to monitor the steps. Okay, in which step what is happening, like that. Okay, so and this and dollar time is there, right? It is used to calculate the time. Okay, and I, I hope someone has missed some classes, right? So they don't know what is this ampersand t, percentage b, percentage b and t, right? So percentage t means it is like a taking every like numbers, like whole numbers, something like that. Okay, ampersand b means like decimal values. It has like a will be only in the form of 0 and 1, right? So we are mentioning that a is only as form 0 and 1 form, so it can be like monitored. Okay, to register that a value, we are going to mention this decimal number. Okay, uh, binary number, sorry, decimal, not decimal number, binary number. Ampersand b means binary numbers. Okay, so a is always in the form of binary number, and t, this t will always be in like number. Okay, it's calculate the total of that number. Okay, so first now we are I am starting with 0. 0 t means start time should always start at 0, and after that you are giving hashtag 10, right? So after 10 units of time, it will calculate another step, right? So in this time, dollar time, it's going to add that time. Okay, see the output. See, first t was 0, and after that it completed the first step, and after that it waited for 10 units of time, and it calculated the next step. Like that, it's going to calculate the time. So t means ampersand t means it is like a number. Okay, whole number or something. Okay, percentage b means binary numbers. Okay, only in the form of 0 and 1. Okay, like that it's going to work. So coming back to this dump file and dump vcd. Okay, First, wait, I will show that waveform also. How it creates the waveform. See here. Okay, it's taking a lot of time to log in. See here. Okay. First, we need to select that iCarnas Verilog for beginner friendly, right? To simulator for running the code. After that, we need to write our test bench code, design code. Okay. So, what is this dump file we have in your code do, right? So, this dump file is going to create a VCD. VCD means it's going to create a EP waveform. Okay, it's creating a waveform which has a file name called as MUX VCD. We can mention anything inside that file. Okay, that should be always in the form of dot VCD. And after that, this dump vars is going to give a level. Okay, zero means okay, zeroth level. Okay, it consists everything. Okay, after that we can change that levels to 1 2 3. Okay, and you are going to mention that for which test bench code you are going to generate that VC sorry EP wave, right? So we need to mention that test bench code. Okay, so before running that you need to see here in my right panel I have something called as open EP wave after run, right? It should be always on. Okay, so after you run this code, the VP wave will look like this. Okay, so why that dump var and dump variables is it? It is used to create an EP waveform, right? So this is how your waveforms generate, like always in like this only, right? So from 0 to 20, like A is 0 and B is changing from like it always change to 1 intervals, right? So this is how our waveform looks like. See here, if cell for cell from 0 to 1 it always 0, right? So 0 to 10 it was 0 for time units of 0 to 10. A was 0, B is 0, and cell was 0, right? So why what are you getting y as is 0 after 10 units of time? Okay, A is still 0, B is changed to 1, and your cell is remaining 0. Then you get output y as 0, right? So it depends upon A. See now A changes to 1 after 20 units of time. Okay, and B value is changing to 0, but your cell value remains 1, right? For first 4 section your cell value is 0. So what you are getting, if cell value is 0 means you are getting y output, y is equal to a, right? See here, you are getting y as an a. After your cell value is changing to, select value is changing to 1, so your output y will become 1. This is how like that code looks like in the waveform. Okay, so that dump fail and dump variables are used to create an ep waveform. Okay, and after that, if I go back to the ppt means, so after doing this, that is how we are going to, like, what we have generated. Okay, this is how that waveform looks like for a particular hardware design. What you have created, like you have created a hardware block for a 2 is to 1 mux, right? So that is how our waveform will look in, like, if you are going to create a waveform, like to study it, the truth table, that is going to look like that. Okay, so this is how we are going to create an ep wave. Okay, using eda playground. So then the next concept we are going to study is 4 is to 1 mux and 8 is to 1 mux. Okay, so 4 is to 1 mux and 8 is to 1 mux means like same like 2 is to 1 mux only, but it's somewhat advanced. Like, oh, so for it is an like it advanced level of 2 is to 1 mux. Okay, so there will be four inputs in 4 is to 1 and 8 inputs in 8 is to 1. Okay, so it's an advanced, like, developed version of 2 is to 1 mux. You guys can say like that. Okay, okay, 4 is to 1 multiplexer, right? So you guys all know about 2 is to 1 multiplexer, right? In 2 is to 1 multiplexer, we have two data inputs, one select line and one output. Okay, so but whether when you compare 2 is to 1 multiplexer with 4 is to 1 multiplexer, 4 is to 1 multiplexer means 4 output to the one, sorry, 4 input to the one output. Okay, so do you have any ideas about how many select lines will be there in 4 is to 1 mux, guys, in the chat? Okay, yeah, two, not three. There will be two select lines in 4 is to 1 mux. Okay, so there is a one formula. Okay, 2 power n. Okay, for multiplexer there is one formula that is called as 2 power n. Okay, n means number of select lines. Okay, so if you give n is equal to 2, okay, 2 power 2 is equal to 4, right? 2 square is 4, right? So for 4 inputs there will be always okay, 2 power n select lines. Okay, so select line becomes n. Okay, then the formula for like if you think 2 power n. Okay, for 2 is to 1 multiplexer, if the n value is 1, okay, we have one selector lines, right? Then 2 power 1 is equal to 2 only, right? So we have two input, one select lines. For 4 is to 1 multiplexer, 2 power n, if there is a 4 input value means, so if you calculate it vice versa, 4 is equal to 2 power n, what will be the n value to equate it with 4? Okay, so write like this: 4 equals to 2 power n, right? So to equate this value, how to reduce this form, 4 form, we can write it as 2 power 2 equals to n, right? So if you like write like this means you will get easily get the n value. Okay, so n is equal to 2. Then n is equal to 2 means there are two select lines. Okay, so 2 power n means number of inputs, and n means number of select lines. Okay, this is the formula can be derived for like defining a relationship between inputs and select lines. Okay, so this is how that mux look like. Okay, for 2 is to 1 mux look like. For there will be two inputs, one select lines, one output, right? So like that only we have 4 is to 1 multiplexer. What does this 4 is to 1 multiplexer do? Like it's simple, like to pick something from an okay, something from a circuit. Okay, like to pick which input we want, we need select lines, right? To that need to be passed to output. So what is the special of this 4 is to 1 mux? Can anyone answer in the chat? Guys, using double select lines, it will take 4 inputs to get one output. N select lines. Of- No, no one, na? Okay, I will only explain. Look, so using two select lines, okay, to select one of the from output input signal, we are going to use two select lines to select from four inputs, right? So from that, using two select line means you are generating a two bits. Okay, this is select using select lines, you are going to bit generate a two bit selection combination. Okay, so what does this two bit generation do? Like it makes easier to carry the signal. Okay, so think in 2 is to 1 mux, it is like you are using one bit select lines. Okay, which will take somewhat load, but using 4 is to 1 mux, it will double that load carrying 2 bit code. Okay, so that is the special of 4 is to 1 mux. Okay, just keep that in mind. Okay, so for to give a real life example, like imagine a four students want to speak on one microphone. Okay, so only one student can speak at a time. So the teacher uses two switches to decide who gets to the microphone. Okay, so using the two switch, like a 2 bit code. Okay, 0 0 0 0 1 or 0 1 0, like that. Okay, then using like that two switch code, then the student can like he has the ability to speak in that microphone for selected student. Okay, this is how 4 is to 1 multiplexer works. So coming back to the ppt, like this is how our truth table looks like. For uh, select line 1 and select line 0. Okay, these are the bit codes. Okay, to remember this truth table, like I see here, I have mentioned one memory trick here. Okay, so select line 1, select line 0 in binary directly gives input number. Okay, so like you all guys, I think you guys know about binary value, right? So what is the binary value of 0 0 0, right? 0 1 means 1, 1 0 means 2, 1 1 means 3, like that. Triple one means 7, right? So seeing the true select lines, if the select line is select line 1 and select line 2 is set to 0, then the output will be depend on select line. Okay, if select both the select line is 0, then the adding that binary value, you will get output as 0. 0 1 means 1, like that. Oh, we are going to remember the truth table. Okay, so coming back to the like boolean equation. Okay, just I will give a task to like study this boolean equation on your own. Okay, so in for 2 is to 1 mux, I have thought like how that boolean equation works, right? So just try this boolean equation for 4 is to 1 mux and 8 is to 1 mux. Okay, on your own. Okay, just try to solve that what I have taught in the previous class. Okay, so and the next concept will be 4 is to 1 mux using 3 2 is to 1 muxes. Okay, so sometimes you interview asks us like build a 4 is to 1 mux using 2 is to 1 muxes, then you are going to use 3 is to 2 is to 1 mux. Okay, so this is our implementation looks like. First you are using input 1. So what is the main components like present in a 4 is to 1 mux? There will be 4 input values, 2 select lines and 1 output, right? So creating like this. Okay, tree structure. Okay, this is how tree structure looks like. First 1 mux. Okay, 1 mux means 2 is to 1 mux means it will always have 2 inputs, right? So giving input 1 and input 2 to 2 is to 1 mux. Okay, with select line 0, and input 2 and input 3 to mux 2 with a select line 0. Okay, after that you are combining that output to the second value. Okay, so if input is 0 for this one and the select line is 0, then always it carry input 1 here, right? So then for output of mux a becomes 0. And here if input 2 is 0 and input 3 is also 0, if the select line is 0 means it will always carry the first input, right? So this is how the input travels, and 0 0, and here comes the 0 0. So if the select 1 is 0. Okay, and you are getting both as 0 0, right? So it always select a value. Okay, which is from the a value, where it is coming from, the value which is coming from mux 1, mux a. Okay, the value which is coming from mux a is going to select when select line is 0, right? So for all the values 0, both the select line value is 0, you are going to get output as 0, right? Like that only if you change the value. So here if you change the value of select lines of 0 to 1. Okay, and it will take input from I1 here in mux a, and like it will be think it as 0, and here also select the select line of yes 0 is to 1 means it will carry output from I3, it is 0. And if you select 1 is 0 means what is going to happen? Any answers? Okay, am I not audible? Is now my voice is clean? Yeah, okay. Okay, I need to repeat this task once again, right? So okay, see here. Think you are building a circuit. Okay. Uh, First, I will tell where you are going, like how and where you are going to implement this tree structure. Okay. So think you are designing a circuit. Okay, new circuit. Okay. In that circuit, you in one place you already use 2:1 structure. Okay, 2:1 mux. Okay. So from that you are going to derive this 4:1 mux. I will tell why, because like to reduce some of the circuit, right, to like it will make the task speed. Okay. So if you are building a something gates, like a processor or something, if there is a let's say if the one gate is used less, means it will like the speed will be increased, right? In the previous classes I've explained, like if you use one gate means less, means inside while you are building a circuit or processor, it will reduces the cost of that circuit, and it will help to speed up the task, right? Like that only. Think you have already built a circuit where you have used 2:1 mux. Now you are going to like in that circuit you are going to advance that circuit to like it somewhat using like 4:1 mux. Okay. Now you are going to like writing another 4:1 mux code in that. So what will happen? You know your circuit as both 2:1 mux and 4:1 mux, right? So in their like gate level implementation, while you are going to gate level implementation in like the code will become a gate will become too many, right? There will be more number of gate. So usually your 2:1 mux carries how many gates? In previous class I've said that it always has one not gate, two and gate, one or gate, right? In your 2:1 mux. So if you use that 4:1 mux, means it will double that gates, right? So now think you now you have your 4:1 mux and 2:1 mux inside your circuit. So what does this make? It will make that circuit complex, right? So instead of doing that, you can use 4:1 mux using another two mux. Okay. So it will reduce gates that are being used in 4:2 mux. Okay. So in first level there will be two multiplexer, and on second stage you will be using one multiplexer. That's how you are going to build a 4:1 multiplexer using 2:1 multiplexer. Okay. So why it is called a tree structure? Okay. The connection looks like a tree, right? Somewhat like branches, right? Branches, trees branches, right? So it is called as a tree structure. And the first level reduce four inputs. So what does this tree levels do? First you have four inputs, right, which reduced into two inputs here. And after the second level reduced to one those two inputs to one input. So finally you are going to get one input only, like in 4:1 mux. Okay. So that block diagram looks like this only. Think now first level. Okay, this is the first level, right? Two multiplexer, this is the first level. This is the first level, right? So if S0 is 0, okay, select line, the first multiplexer select line is 0. Okay, then you always get input a is equal to 0, I1 is equal to 0, I1 is equal to 0. Okay. So for this, if your select line is 0, then your output will be a, right? Then a will be here 0, right? So a, what is a here? IO, right? IO. A will become the output of that first multiplexer will become IO, input 1, input 0. Okay. So and also in mux B, if select line is 0, then your input is these two, right? I2 and I3. So the output will becomes I2, because think, okay, think this as a, like this is a 2:1 multiplexer, right? So what does this 2 is to 1 multiplexer do? Think I1, I0 as A, I1 as B. Okay. So when your S select line is 0, it's always going to produce A as an output, right? So now your A becomes I0. So the output of MUX A is I0. And here also select line is 0. Now your A is I2 and B is I3, right? So like that only your then now your select line is 0, so the output will become I2. Now you have I0 and I2 as an input to uh, next level multiplexer. Okay, so second level multiplexer. Now what you have input to the second level multiplexer, that multiplexer C, it has I0 and I2. Okay, so now you have if a select line becomes 0, select line becomes 0 means it's going to collect the output from multiplexer A. Why? Because this is input A, right? And this will be input B. That is how 2 is to 1 multiplexer works, right? So it's going to collect input from MUX A. What is the output of MUX A? I0, right? So it's going to transmit I0 if select line is 0. What happens if select line is 1? Then it's going to produce Y is equal to B output, right? So your output will become uh, the output will come from multiplexer B. What is the output produced by multiplexer B? I2, right? So I2 will will equal to Y2. Okay, Y that will become the output when your select line is 1. This is how the multiplexer works. Okay, 4 is to 1 multiplexer work when you rate in the form of 2 is to 1. Okay, so and this is how our very like using assign statement our multiplexer looks like. See here, like what we have designed for 2 is to 1, right? So don't worry about this 4 is to 1 and underscore assign. Just is an way like module name. We can give anything you want, but remember to one thing is that you have given your module name here, right? This same name should be used in Testbench also to import that this design to for testing. Okay, what does our input have I0, I1, I2. Okay, and we have input two cell, right? So don't worry about this 1 is to 0. 1 is to 0 means there is 2 bit selector. Okay, so selector 1, selector 0. Okay, if you have 0 is to 3 means there will be 3 selectors. Okay, sorry, 4 selectors, 0, 1, like that. Okay, so yeah, yeah. See here, it's always like first selector will be 0 and next selector will be 0 1, like that only. If you give 2 is to 0 means there will be 3 selectors. When you give 3 is to 0 means there will be 4 selectors. Okay, I will explain this in next class to like how to read that. Okay, so don't think about like that, just remember if 1 is to 0 means there will be 2 selector. That means 2 bit selection will be going on. Okay, so just like I told you guys to create a boolean expression on your own, right? Just try to solve this assign value. Okay, yourself. Okay, yesterday I thought about for a 2 is to 1 marks, right? Like how to solve that assign value for 2 is to 1 marks, right? Like following that procedure, try to solve this. Okay, if I start now means it will take lot of time to teach this, so we can continue in the next class. Okay, from writing Verilog code. Okay, yeah guys, you can end the meeting here. Thank you for attending.